Solar Cycle 25 and the impacts on field operations. This is a recorded version of some materials we put together for the users of real-time networks and the surveying and geomatics associations. I always look forward to Lidar CANEX and was a little surprised that I'm going to present at it. This might seem like a bit of an obscure subject, but in many ways, GNSS or GPS GNSS is integral to a lot of reality capture field operations and post-processing. Solar Cycle 25, the potential field operation impacts are for any static GNSS post-processing, the PPK post-processing, used for, a lot for mobile mapping and drone operations, real-time kinematics, space rover, and network RTK, and then multi-sensor systems, GNSS plus, IMU, etc. In extreme cases, the communications that you might be using, cellular base radios. Solar Cycle 25 is named because it's the 25th solar cycle since 1755, when the observations of sunspot activities really began. Coincidentally, it peaks in 2025. This one is it started a little earlier than expected and is likely to be stronger than originally predicted. So what can happen in your field operations if you're using GNSS? Well, longer fix times is chiefly when there's, moderate space weather activity, difficulty in maintaining those fixes, poor residuals when things get worse. Then you could end up with just failure to fix. You could be stuck in float indefinitely. No GNSS at all is possible, and as I mentioned, in extreme conditions, it can affect RF communications, cellular and radio. A lot of people use cellular for the NTRIP connections to, say, networks or IP-enabled bases or base and rover radios. This is from Space Weather Canada. The possible impacts of space weather from the geomagnetic activity. But they list, across the board, power systems, aeromagnetic surveys, examples like directional drilling. This is a very handy little chart. We looked at some of the solar storms so far during this cycle, looking at the user experiences from real-time network, the one in Washington State. And then this is expressed in what's called the I-95 ionospheric index, which was specifically designed for impacts on GNSS. I'll explain that a little bit more later. So the I-95 is computed from local stations in a real-time network or a series of permanent bases. So it doesn't predict, but it shows what happened updated on an hourly basis. And the scale on the left is the expected geometric error that would happen with unmitigated GNSS observations. So Friday, May 10th was a particularly large storm, the largest in 20 years. In the morning, it looked quite normal. By midday, it started to rise. And by the evening, it really went off the chart. But by the next morning, mid-morning the next morning in local time, Pacific time, it had calmed down to normal again. So it was brief, but very intense, the largest in 20 years. There was I think it was the Halloween storms 20 years ago, was, slightly smaller. This one's called dubbed the Gavin storm. For the scientific analysis, they've named it that. Here's another view of it. Now, this isn't the I-95 scale. This is the KP index. And the KP index is very handy because a lot of the prediction resources are expressed in that. This is out of observations in Potsdam in Germany. And this is the same Gavin storm. It tracked the I-95 evidence, what was predicted, and they paralleled each other very well. So we did an analysis of the real-time network users in Washington State, talked to operators using Basin Rover and other networks around the U.S. in Europe. And the effects noted by users, well, it was the slow fixes, no fixes, poor residuals, and cell issues. It's not the same for everyone, though. And that's because there are some mitigation features. The operations side of a real-time network, no processing issues. The rover monitors, permanent, rovers set up to just observe the quality of a network. They really showed no effects, but they were newer rovers or newer base receivers with great antennas. The residuals were still good, and there were few user calls to these networks, except, and I got an asterisk there. So what we found out was that newer multi-constellation, and that's a really key in being able to ride out these solar storms. Multi-constellation with ionospheric mitigation features. These are like a lot of rovers built within the last 5 years. There were no issues at all. Same with the base receivers on the networks that were the newer generations. Now, older multi-constellation, they may have been 2 to 4 constellations, but older ones, some experience slow fixes. The old dual constellation and single constellation receivers, GPS and GLONASS are just GPS only. Slow fixes, no fixes, very poor performance. And here's the asterisk. Low-end GNSS boards and antenna rovers really had struggle. They weren't fixing, or their post-processing was, off the chart bad. So the example of what I mean by these low-end boards, there's some very affordable GNSS boards that designed for autonomous systems, but they've been deployed on drones and very low-cost rovers. So it's balancing the risk, the risk analysis. There may be a number of days during the solar cycle where you just can't use these, or it's just not wise to try to use them. That's where the prediction tools come in handy. Otherwise, high production outfits, a lot at stake, big construction projects, they can't really afford for any seemingly random downtime. So they go with the more expensive gear. So in another storm we looked at was August 2024, which was not as big as the Gavin storm. Again, it was brief, very intense periods in the overnight. No significant issues reported except for the low end equipment, and we tracked it and looked at how it tracked with the KP index, and then in particular how it was predicted it was going to happen. So past solar storms, many years ago, in 89, 2003, 2000, 86, looking at those, the Gavin storm was particularly big. It was like the October 2003. So what happens when this goes on, without going into a lot of details, because I don't understand all the details, I rely on atmospheric space weather experts to kind of explain it to me. You in a solar, say a heightened solar event, that could be solar flares, coronal mass ejections, CMEs. So you have energetic electrons can actually damage spacecraft, although a lot of them are hardened, as the GPS and GNSS satellites are. And the protons, the solar flare protons will affect even the GNSS ones. So you have the ionospheric currents, and in that you have the GPS signal going through it. You also have scintillation, which we're going to talk about, which is a kind of a double whammy. radiation effects on avionics, high frequency radio wave disturbance, geomagnetically induced currents and power systems. So what you get when it comes to the GNSS is you get ranging errors, because those delays through the ionosphere, because it's very heightened, are much harder to gauge and account for. And then you have scintillation. In the lower left, it shows this is patterns of peak ionospheric activity that are, around the clock. It happens usually when things are normal at very predictable times. It used to be an old rule of thumb in the old days is when we only had a few satellites was, well, observe at night, and the ionospheric activity is lower. The lower right, we have the geomagnetic equator, which really gets hammered hard, and the northern latitudes, northern Canada, Alaska, northern Europe. So scintillation is kind of a wild card in this. Scintillation goes on all the time, except during heightened solar activity, you're getting a double whammy. It's like compounding the issues. But scintillation is more acute, small scale, say, bubbles in this ionosphere. And when that happens, you might not be able to do anything for a very brief period. And it can hit very randomly, very hard to predict these individual bubbles. But they do map the heightened total electron content, correlate that with, scintillation effects. Again, more in the northern latitudes and the geomagnetic equator. The mid latitudes are rarely affected. To give you an idea, the very southern part of Canada and, Washington State across the northern part, considered for this purpose a mid latitude. So it's higher than down lower, and it starts to go back up very high, and you get down towards the geomagnetic equator, Central America, northern South America. Okay, there's information resources, because I can't go into everything, and I'm not versed in everything, but the NOAA Space Weather Prediction Center has a lot of background materials on this. Hexagon, Novatel, Leica, they have a really great resource page, and they're talking a bit more about the GNSS. When you go to the typical space weather resources, they're talking about it in a broad range, from the scientific purposes to, the effects on transmission lines and other things. Trimble has a great resource site as well, TopCon. There are others. You check with the vendors of your particular equipment, they probably have a resource page. It explains more focused on what's going to happen with what could happen with the GNSS. So there are prediction tools. There's the strategies that you can put in place so that you're not disrupting your work as much. You could plan ahead for a day when you might not want to be doing something. You might not want to be doing your typical field operations that reduce, unaccounted for downtime. So these prediction tools are actually quite good. We've been tracking over the last 18 months, and it's hitting, pretty much exactly what they're predicting. The NOAA Space Weather Dashboard, I'm going to give you examples of some of these. There's a GNSS planning tool that has put some of the predicted in it in the current conditions. Space Weather Canada, which has a particularly good, helpful site. I use that here in Washington State, actually. Total electron content is another gauge of what's going on. There's a 3-day outlook with NOAA, which is, as I said, it's proven to be very, very, very good predictions. There's a 27-day outlook. It's a little aspirational. It might give you an idea of a period that might be coming up where it could happen, but really the 3-day outlook is the best tool. So a quick summary of this is the Space Weather Canada site, through the NRCan site. and it gives you this KP index here. They do a 24 to 48 hour forecast, which is very, very good. They've got it color coded, and then they've got the activity levels and the KP index there. So here's the NOAA forecast, the 27-day forecast. They use different scales for certain things, but that's useful to different activities and different sectors of industry and science. So as I said, the KP index is the most commonly used in the predictive, but you'll notice over here in the 3-day forecast, they actually will label when it reaches a KP, predicted KP of a certain level, the geomagnetic storm classifications of G1, G2, G3, and so on. You hit G5, that's don't even G5 or above, don't even try. So there's the estimated KP through NOAA and some other resources. The Canadian one, I think I've mislabeled this, the total electron content. It goes into a lot of esoterics, but it boils down to KP give you the good predicted, and the I-95 will show you what actually happened in your region, because it's not going to be exactly the same everywhere, but it'll give you an idea of what happened on that day. Together with your own experiences with your own equipment, you can build some rules of thumb. So here's an example from a real-time network. A lot of real-time networks are tracking with their own stations and deriving the I-95 indexes. So in this case, in the Washington State real-time network, you can go and hit the predicted, link to NOAA, but also you can look at the I-95 for a particular region of the state and see what happened there. It varies a little bit across regions of broad area. It's going to vary actually quite a bit across the Canadian provinces as well, not only in the time period, but it could be more intense in one and another. But within a few centimeters of this predicted geometric error, if it's unmitigated across the provinces. So the I-95 index, green is low, no activity, no effects. Yellow, normal conditions, still typically no effects with modern equipment. Yellow to red, moderate conditions. You may start to see some of these longer fixed times. Now, red is high. It's high activity. If it's above 8 for more than an hour or so, that's when people are really getting hammered. No fixes. It can even go to no GNSS, and you might start having trouble with your cell or your radio. And this pulled a bunch of data so I could show just how high it can go. So non-mitigated, going up to, if it can fix it all, 18 centimeters of error, although beyond 10 centimeters is not truly fixed anyhow. So prediction methods. There's some finding out that users in Europe and North America have come across this from the last solar cycle. You check the KP index on the prediction sites. Then during the event, or after it, you could look at the I-95 and see how they line up. Compare your field experiences to the plots. Some users built spreadsheets and they went, okay, with their particular gear, like I said, not all gear is going to be the same. Not all gear is going to mitigate it the same. Not all of them have the ionospheric mitigation tools that for a lot of rovers have only really been put in place in the past few years. So you can build the rule of thumb, when you look at the predicted and go, for our particular equipment in our part, in our region, our latitude, we might not want to do certain things, do certain tasks on these days. We might want to think, alternatives or delaying to another day. So the mitigation approaches, and this can vary a bit. So very short base rover baselines might help. If you have what somebody calls a site base, you've got that base station, you can see it on the construction site. you might fare better than if it was much farther away, 10 kilometers or more. But when conditions get to a certain point, it's the same effects on the base as the rover, so that's not going to help. Network RTK is by nature more resilient than single base under most conditions. It's modeling over a broader area, modeling the ionospheric delays and so forth. Now, receiver mitigation. Manufacturers have been adding space weather resilience features. And in some of these, it's just an update of firmware. In others, you can't, reverse engineer this into some of the older rovers. So with a lot of the newer ones, just keeping your firmware up to date, and you might have your iono mitigation capabilities. Working at night was kind of a misguided old rule of thumb. I mean, for example, many of the recent peaks have been at night, which has been fortunate for a lot of end users that typically are working during the day. It has a lot more to do with when the event happened, the solar event happened, how long it took to get to the Earth to, a coronal mass ejection, maybe a day or two before the full impact is felt. So yeah, working at night, no, that's not. Using the prediction methods, and keep your total stations handy, or take that day off. Here's an example of a receiver mitigation tool. So improved tracking is the key to it. When, it's changed a lot. GNSS in general, you've got 4 or 5, 6 constellations. 4 are in North America typically. And you've got not just the, one, we started with, one signal, L1, and then L1, L2 dual. Between all the constellations and all of the signals that they put out, E5A, E5B, E6, E1, Beidou B123, B33, et cetera. There are 21 usable signals. With the improved tracking, the solutions that are put under one giant filter in the rovers can mitigate a lot of this and reject a lot of things and gut check each other. So base network application plus rover applications, these mitigation measures are being applied at the bases in the network software to some degree, but in the rover application. The field software that you use with the rover may have an ionospheric stoplight, like a stoplight indicator for each satellite. So when you look in your field rover and you're having some effects and you see some of them going yellow or red, some satellites that are in the orientation of where there's more intensity of it, you could actually just take those out of the solution. A lot of the rovers will just take out the bad ones, or the ones most affected anyhow. You could, disable them manually if you want to. We're going to go into the Q&A session. It's a bit of a wrap up on this. GNSS is integral to so much reality capture. Your mobile mapping, GNSS plus IMU, your drones, GNSS plus IMU, and any of the related post-processing. So, well, thanks for listening, and we're going to go into the Q&A session now.
Gavin, thank you very
Hi,
much
Tim.
for that most interesting talk and very informative. I really enjoyed it.
Oh, thank you, Tim.
I think you said it at the end how GNSS is so ubiquitous in so much of what we do in the LiDAR world, reality capture, wide airborne mapping, and so forth. I know myself, I've become a bit complacent, just assuming it's there, assuming it's going to work 24/7. So I think this was a really great time to have a talk to remind us all of the impacts and the pitfalls of how this activity could influence us and affect our results and our operations.
Sure. Yeah, there's a question here. Somebody
Okay,
asked, they
very
said,
good.
yeah, if a LiDAR vendor flew during that intense storm, say in May of 2024, give an idea of how more inaccurate the resulting point cloud could be. It's actually more of a case of it's not going to let you process certain signals from certain satellites. You will just end up with less data. Now, because you've got satellites in one direction that are may not be as affected by the that solar activity, say out to the west, but the ones to the east, it's just going to reject those if it's intense. If the ones in the other direction can meet the thresholds, and well, you're going to have bad geometry because you might only have a few satellites. You're going to have bad geometry. Same kind of thing as if you don't have enough satellites. If you're trying to post-process something, you do a terrestrial survey and you've got canopy, you've got blocked or signals. So I've never heard anybody say, oh, you're just going to miss by a few centimeters or you'll miss by decimeters. It's sort of like you're either going to be able to do it or you aren't. And if you do, you could have just wild outliers. Which ones of those are good? Hard to say. But, the old days of post-processing where we'd manually go through and try to triage, you may be able to salvage something depending on the conditions. But really, we were flooded, our network and some other sister networks were flooded with calls from people doing their their drone work.
Mm.
And a lot of that had to do just with the very low cost boards that just, they're not set up for that kind of thing.
No, and I think you made a good point there, um, regarding the different types of equipment, the latest equipment from the higher end, um, the Trimbles, the Leicas, that suite of higher end receivers, seemed like those people were able to manage not too bad. Um, we've bought some low cost, survey grade equipment, the Reach, for example, um, that we've used in different occasions. Have not really come across this in our practical experience, but you got to wonder when you can buy a drone, a LiDAR, and an RTK system for 50K. The quality there has to be a price paid for the quality. That old saying, you get what you pay for. Um, so that's real interesting to know, and I guess it really a big message to people in the drone operation world. Uh, Perhaps even more critical to look at the planning side of things than folks with higher end receivers, et cetera, that could apparently handle this kind of disturbance.
Sure, very look when it comes to RTK, there's no secret to it anymore. You can buy I've done it. I even bought a $5 chip one time and
Hmm.
built a rover out of it. If I'm out in perfect conditions, I don't have multipath, I don't have canopy, and I don't have a bad solar day, I can match what a 25-year-old, rover can do. I can get my centimeter stuff, but it's depends on what your stakes are. If you're willing to live with a few bad solar days, are you planning ahead? Yeah, no problem at all. No slam on the no pun intended there. No slam on the low cost gear at all.
Yep.
Although as a network operator, most of the calls I get are people with low cost gear. It's just, it's a trade off. As somebody said, you don't enter the Le Mans 24-hour race with the 1980s Yugo. I mean, both vehicles have wheels. They're going to get it around the track. No, I'm just kidding. So, oh, I saw another question.
Yep.
Yeah, can I fix a bad solar day by post processing? No, the base where the data is coming from is similarly affected. So that's you can't process your way out of a bad solar day.
Another follow up to that one. If I have a top tier newer base, but a lower tier or older rover or drone, will this mitigate the bad solar?
It's the same situation.
Yeah,
It's affected. It may not be affected, but it's all on your rover at that point. So
sure.
yeah.
Yeah.
Mhm.
Um, I apologize if I missed this during the session, but can you get solutions, fix solutions, but yet have the higher error associated with them? Did I understand that correctly?
Yeah, that's differences in RTK engines. Some of them use this Boolean, I'm fixed, I'm not.
Right.
Others do a sliding scale. The Boolean fixed, okay, if I manage to get a fix because I just happen to have enough to do it, how often is it reevaluating that?
Hmm.
The other
Right.
ones, it's a sliding scale. It's processing all of them, and it's not setting that fixed float. You know, if you're starting to see residuals above 10 centimeter, well, you're not truly fixed you wouldn't be truly fixed anyhow. So,
Right. Right.
mhm,
Yeah, no, I mean, first off, it's just fascinating technology. The whole idea of that,
mhm.
those 19 centimeter waves, being able to track that full wavelength and so forth. And then, again, thinking about the physics of what happens in order, as it comes from the satellite down through the ionosphere to us, and these perturbations that are happening there. So you mentioned about a lot of these activities happen at night, and of course, we saw some beautiful photos on the internet of different auroras and so forth that people captured, and those were the events where you saw your most calls, or people were having the most trouble, or even though they happened in the night, were they also sort of active in the day that we just didn't know about them? Do you know what I'm getting at
No,
there?
it's a function of when the event happens at the sun.
Mm-hmm.
You got a solar flare, or coronal mass ejection. How long when it gets
Right.
to the Earth, maybe day or night, depending on when it happened there. So
Sure.
we kind of lucked out this year. Well, actually, there've been like five pretty big ones, but the two that I showed just happened to happen at night, which was great. Except we have hydro customers that run around the clock, some autonomy and robotics that run around the clock. Um, yeah, we've kind of lucked out, but there have been some, in the past that hit during the day.
Mm.
And during the day, I mean, the ionosphere, this is a mischaracterization, kind of puffs up during the day. It's you got direct sun,
Mm-hmm.
exciting
Mm-hmm.
everything. So, but when it comes to the solar storm, it's a function of when it left the sun and when it gets here.
Right. Right. I'm going to ask a real simple question. They say there's no dumb questions, so I'm going to ask one. In the world of aviation and like landing aircraft and so forth, um, are they just using code solutions, or are they at the stage of phase fix solutions? And if so, what are the implications around that?
Okay, so I'm not that well versed in the aviation. They're using like the wide area solutions like WAS.
Wasp, yeah.
WAS, I'm not sure what the status is, but the L1, L5 on the WAS, it's you're functioning more like an RTK.
Mm-hmm.
There are landing systems that run. I think one acronym was an APS that's going to full fixed because it can. I remember the one example in the runway in Australia where they were testing some of it, and it kept putting marks in the same spot in the runway because it was that precise where
Wow.
the wheels hit.
Hmm.
But no, typically, and there are multiple systems involved. That's the other thing is the multi sensor stacks are going to be a real godsend for GNSS and other technologies, LiDAR are actually in the stacks. But when you have other things that act as a canary in a coal mine, like, oh yeah, you've got another sensor source, the geomagnetic navigation, that there is, it could let you know if you're being spoofed,
Hmm. Hmm.
jammed, or if it's heavy solar activity on your solution.
Hmm.
So
Interesting.
good things ahead.
Yeah, yeah. I would assume too, talking about geomagnetic influences, anyone doing any kind of geophysical survey related to magnetics, probably I'm assuming that would interfere with those kind of surveys. Any thoughts there?
Oh yeah, yeah,
Yeah.
yeah, yeah. There's definitely those. Like I said, they're looking at different scales in the geomagnetic activity that to help them gauge the effects on what they're doing.
Mm-hmm. Mm-hmm.
So that could be a challenge to, there's the quantum geomagnetic navigation that they're being experimented with. That would affect it. But then again, that's you're only looking for precisions of a ship-sized, not a 1 centimeter survey tack. So
Right. Right. Another question's popped up here, Gavin. Was any analysis done on the October 2024 event? How did it compare to the May event, and did it also peak at night?
the I it'd take me a while to look it up here on my computer. The October was not. Yeah, no, I like my shirt too. Somebody said. So
Pink Floyd, I think.
yeah, yeah, dark side of the solar flares. The October was not as bad as the August and May.
Okay.
May was the biggie. August was close. October was notable. I believe we also had it was night and early morning our time here in Washington State.
Uh-huh.
So yeah, I know the hydro people are going to call me.
Interesting. And is that because of the fluctuation of their grid, you were saying?
Yeah, yeah, um they were having trouble maintaining a fix throughout their just, the boats moving around in the
Oh,
sound.
oh,
And
when you say
so
the hydro, you mean hydrographic surveyors.
the hydrographic
Okay.
survey folks are the ones that work around the clock
Okay.
often. There's some mining robotics, some robotic delivery vehicles they just stop when they're not fixed, you know.
Okay. Wow.
So
Wow. Yeah. Interesting. Really, really fascinating activity. And I don't see any more questions. Um, that's my image I use to explain refraction to my kids. Somebody just put there that prism
oh yeah,
is something that's used to explain that to their kids. So that's great. You're going to
cool.
join us in the panel, I believe,
I
at
guess
the end,
so.
Gavin.
Yeah,
So I look forward to that and further chatting.
right
Again,
on.
real interesting talk, and I think something that maybe a lot of us just take for granted. And obviously, we need to be thinking and looking and appreciate also showing us those different tools and predictive tools that one could use, especially those working in that drone environment and so on. So thanks again.
All right, live long and process.